The broadcast is now starting. All attendees are in listen-only mode.
Hi, good afternoon. Good afternoon, everyone, and welcome to another webinar. It's nice to see some frequent attendees on our sessions. My name is Bruno. Probably you'll know me if you attended before. Today we'll have a special guest as well, a specialist on this topic. He will guide you throughout most of the presentation, and we hope that it's going to be informative enough and that you can answer all your questions, that you can clarify some of the doubts that you have. And in case that you might need some more information, you always know how to reach us, and it's very easy. The emails are going to be shared, so it's quite easy to get in touch with us. I hope all is well. I would just like to ask a question to our attendants. Where are you logging in from? Just type it out in the chat so we have just a better idea who we are speaking to and what are your expectations for these kind of sessions, so you can try to address some of those. Nice to see you all. In about 2 or 3 minutes, we'll start. We see some people that are just joining now. All right, so welcome to another webinar hosted by Hira Walraven Academy. This is part of a series in which we talk about how we can tackle some of today's most challenging problems. And previously, if you logged in before, if this is your first time, but previously we talked about heavy installation solutions, how to protect your installations from corrosion, and then how to combine those two topics to design reliable weather-exposed fixing systems, such as ones found in rooftops and outdoors in general. The last webinar we did was actually on the topic of rooftop installations, how to design efficient solutions for this equipment and all the ducts, all the cable trays you might find outside in rooftops typically, and how we can solve that issue and we can work with you to create better fixing systems for this. Today's topic is also a continuation of all of this safety and efficiency MEP installations trend that we've been progressing from early in the year. And this time we're going to focus on a key aspect of proper engineering buildings, seismic protection. In this webinar, we'll talk about how earthquakes affect all building systems and why it's crucial to extend the design to the non-structural components. You can visit our social media pages to access recordings of our previous sessions. You can then refresh your knowledge, or you can learn something new. And for more information, as always, don't hesitate to get in touch with us. So now I will just give you a quick introduction on what's going to happen today, what did we plan for the session, who we are as well. And for you today, we have a duration of about 45 minutes, so from 3 to 3:45 approximately. Of course, if need be, we'll just use a little bit more time to explain a bit more in detail some of the concepts we're going to talk today. Then we'll have, after that, a question and answer duration of 15 minutes or 15, 20, 25, depending on how many questions we are getting from you and how much time it will take to answer all of them. We always try to answer all the questions we get from the audience, and this time will not be different. So if you have questions, you can always type them out in the chat box or in the questions box, and then later on we'll get to each and every one of them. So the content we planned for today, we'll start with a quick introduction on our company, so who we are. We'll then move to why it's important to consider the seismic activity, the effect that it has on MEP systems, what kind of bracing systems are there and that we can offer. And then we can help you design to account for this effect and these forces, the design methodology to create solutions for that, and we'll give some application examples. So to start with who we are, first of all, let me just talk a little bit about the Hira Walraven Academy. If you've been following, you already have an idea of what it is. If it's the first time for you, I'll explain. This is a concept we launched early in the year to educate and to try to train not only our own people, but always also our partners, the industry partners we work with, the contractors, the consultants, the clients, the developers, everything, about some of these highly technical topics and some of the challenges that we face today in our world and what we can do to counter that. To sum it up, we just prepared a quick video. I'll just play it out for you. So thank you for staying with me. Of course, the Academy, it's not only our training sessions and webinars such as this, also seminars, also coaching on site. It's everything that encompasses the technical knowledge that we have and we want to share. So you see in the video part of what we do as part of the engineering support services that we have. This is also part of what we call Hira Walraven Academy. So Hira Walraven, we are a successful joint venture from two companies, Hira Walraven, that came from a company based in the UAE, which is Hira Industries and Hira Group. And then in 2015, created a joint venture with Walraven Group based in the Netherlands to form a much more efficient company, and let's say company that can answer more problems and more complex problems. So this is how we came to be. And just to give you a highlight of what Hira Industries is, this is a company founded in 1980 with sales companies and manufacturing units in multiple locations across IMEA, so Asia and USA all the way, and currently employs more than 1,100 employees from more than 20 plus nationalities. Walraven itself originated from the metalwork company Hira Walraven in 1942, has currently production and sales companies in more than 15 countries, over 1,000 employees, and it's a very innovative company with more than 60 patents and counting. So we have a global presence, and we are highly specialized in this kind of field in the MEP application industry. Not only that, of course, but this is the core of our expertise, and we've been tackling all the issues that has been showing up and has been developing since the 1940s. So this is how we can help you with all of this knowledge and all of this development, all of this technology, all of this expertise. This is where we can help on every kind of project you have and every kind of problem you have. We can be there to help you solve it. Hira Walraven at a glance, we have manufacturing plants in UAE and India, sales companies across the region. We are a manufacturing supplier of complete fixing system solutions from simple pipe support to vibration control and seismic. Part of how we guide our work is quality. We are ISO certified, we are RAL specified and MSS member, and we design solutions to meet the most demanding quality standards, such as FM, UL, VDS, ETA, and of course RAL, which is a framework of pipe support quality as well. We offer a vast range of solutions, such as certified installation systems, like pipe support, channel and rail systems, rooftop supports, as I discussed last time, vibration isolators, and of course seismic, which is going to be the focus of today, and high performance mechanical and chemical anchors for seismic and non-seismic applications. So how do we help you? We market and brand all of our products under the name Diamond Walraven, and to round it off, we offer anchor design services. We do field testing, both to comply, to prove our performance, as well as to check the situation at site if the substrate has enough strength or enough reliability to actually support what's needed to be. We do customized and tailored solutions, and we help you throughout the whole process of seismic design, which can be sometimes cumbersome, and there's a lot of steps, and we can help you throughout the process and guide you with everything that needs to be done. So we have decades of experience, such as landmark buildings across the world, transportation networks as metros, railways, roads as well, tunnels. All of these kinds of special solutions projects we have worked on, and we have several solutions tailored for those. High-rise buildings, which present also a lot of issues, especially on the dynamic part. So, of course, seismic not only, but side vibration, wind, all of these things we have studied and designed, and we have been working since a long time, since decades now. And we are specialized in these kind of solutions. And of course, mega developments, iconic developments such as the Expo, which we are eager to see next year. Unfortunately, it was not possible this year, but we are almost turning the page, and hopefully next year will be much more positive for everything. And we hope that Expo will be a part of that. So our values, which it's something that guides us as well, and I'll just showing this to you so you will always be a part of that. So think smart is something that we value very much. This is, of course, part of thinking out of the box and creative mind to find better solutions and more efficient solutions for your projects and your problems at site. Fair play and transparency, it's something that guides us, so we are not cheaters. We want to respect and be respected as well. And most of all, we are honest and open. For every situation, we do not hide any. We are transparent with our industry partners, our clients, whoever we work with. This is something that guides us as a company from inside and outside. Open communication is, of course, a part of transparency. So the freedom, the flexibility, and being approachable. This is what guides us as well. Be accountable, of course, being reliable and being trustworthy. This is a mark and the mark of quality from our company, and this is how we position ourselves in the market. And of course, to challenge ourselves to be unique and to be innovative and to never give up. This is our core values that guides us as a company and as people that work for this company, and ultimately the way that we better serve you as a client, as a contractor, as a consultant, as a developer, as a partner. So about today's presenter. Today's presenter is engineer Haris Qureshi. He's a senior technical engineer specialized in seismic and vibration control, has more than 6 years of experience in the construction industry, especially in the construction services industry. Companies such as Hira Walraven. He has a vast experience on this kind of solution, so he knows very well how to navigate all of these situations, all of these issues. He has more than 3 years leading seismic technical departments. He specializes in seismic and vibration control systems, and his background is in mechanical engineering. So he's the right person to address for all of the situations, and he can guide you for everything. Haris, please.
Hello, everyone. Good afternoon. Thank you so much, Bruno, for my introduction. So our today topic is about seismic and vibration control system, mainly the seismic restraint system for this all MEP and HVAC firefighting all system. So as for the contents, like importance of considering the seismic activity would be our first topic to discuss. This seismic importance and what is earthquake, just kind of introduction for the earthquake. So let's start with this introduction. As you all know about this, earthquakes are unavoidable and it could occur like any day, anytime, and we never knows about the earthquake and we cannot even forecast. We can just like based on some estimation, we can like design some construction or design some from engineering point of view, we can design the system only. So, and this earthquake, it has we have some contribution of this earthquake, which I can show you here. In 2019, you can see this over 1,600 events were there, and this with a magnitude of 5.0 m, and higher registered also, but several events with 7.0 m. So this is the very, like you can say, it's very huge impact as per this data, and the overall this earthquake impact is like around, for the economical point of view, it has $365 billion. It's like which was recorded in 2011, and more than half of this value is from Tohoku disaster in Japan. So events occur all over the world, including the Middle East. And as you all know that we are working in Middle East, so this market and this all design consideration for the seismic or earthquake point of view needs to be considered very well while designing our system. This when we talk about specifically for Middle East, it has some data also which showing some events and some how the region is changing. So, and seismic events are getting more severe with when we are comparing this data since last couple of years. So this seismic events are also in this region are frequent, and this one of the, you can say it's getting more active in the regional point of view. More than 700 events were recorded in last 365 days, and majority is above 5.0 m. Seismic map is constantly changing, and it's like things are getting changed, so we need to be more proactive while designing any system. So that is why seismic design is must for any MEP system or any non-structural system design. Here we have some introduction for the earthquake, how it is arrived, what is earthquake. Earthquake is basically like movement or the sudden changes in the plates in the soil, and because of those changes it released some energy on the surface of the earth. That's why we are feeling some earthquake. Here we have two technical things like hypocenter, the point of origin where earthquake is originate, as you can see in this picture, and the epicenter is a reflection of all these energy on the earth surface. So just be on a more specific side, this is kind of better introduction for our consideration for earthquake, and then to understand the system overall. So when we talk about earthquake, then it obviously every force it has intensity. So earthquake also has some intensity, and we have different scales to measure the earthquake intensity. And this, as you can see here, intensity is categorized by different numbers. And we have also this Richter scale, and then we have also Mercalli scale. And Richter scale is used for to show the earthquake how intense it is. And then for technically we have peak ground acceleration, which is in terms of meter per second square. That would be useful for our designing for our designing part. Then we have this data which showing the magnitude, intensity, acceleration, perceived shaking, and potential damage. This magnitude from 1 to 9, we have in perceived shaking we have nothing. But when you compare it with this 5 to 5.9, which is, you can say it's a common one. It could be happened. So that's why perceived shaking is very strong, and potential damage is moderate, but it has. And intensity is in its rate is 7. So this kind of data in different magnitudes or different different parameters, we can consider this earthquake intensity to design or to design any system for earthquake protection. And peak ground acceleration would play its major role while we are designing anything related to the non-structural. Then we have this some map details which is based on this seismic force in terms of G, and we have different this Middle East region. It has showing on the basis of different different years span. Let's say 50 years span, we have collected this data 0.75 G, which is represented by blue color in this chart. So it's basically the intensity of seismic force. Intensity of seismic force is in terms of G, and this is in different regions it has different value based on different data collection in the air span. So 50 years data showing some values, and 100-year data, 250-year data. So different years data having showing different seismic forces based on different regions. Then for specifically for in terms of peak ground acceleration, it has, while we are discussing this region, so we are here in United Arab Emirates, and so we can see here in United Arab Emirates it has all this 0.2 to 3.4.0, all categories lies in this region, and then all system needs to be designed accordingly. So this is the just general concept for the earthquake intensity and the peak ground acceleration, intensity in terms of peak ground acceleration, which is useful for our any seismic design. So seismic design is not about just the seismicity. It's also based on the depends on the type of structure, nature of occupancy in terms of technical language while we are speaking. So nature of occupancy. So we have to design different system in different nature of occupancy. Means if you are dealing with firefighting or some police station, rescue stations, so you are dealing in more different way, while you are dealing with some kind of stadiums and arenas and power plant and medical facility. These are different like nature of occupancies, and we have to design our system in different ways with respect to the nature of occupancy. So as per this IBC table, we have four, as you all know about these four risk categories, which is 1 to 4, and it starts from 1 and it's getting more severe to 2, then 3rd, then 4th. And all this 1, 2, 3, 4, it has different kind of occupancies, which we will discuss in this session also. What kind of buildings are covered in this 1, 2, and 3, and 4. So when we are dealing with, as you all know, that we are dealing with non-structural equipment, non-structural services, and when we are talking about the funds point of view, economic point of view, the major contribution was for the non-structural parts in any building. So major investment is for your non-structural system, while we are comparing with the structural system, because we have HVAC system, MEP system, all services in each. Even MEP, it has lot of different services and the equipment cost. So everything, so majority is involved for the non-structural items or components in all our construction industry. So when we talk about the investment point of view and costing point of view, so we have majorly out of this in non-structural component system, we have in non-structural we have MEP, which includes HVAC, electrical, life and safety, all. So while we are it has some, this data is showing we have major contributor was HVAC application along with the electrical installation. For life safety is playing its role, but the major contribution for the investment point of view, for the costing point of view, is HVAC and electrical system, which covering the full range of all. In HVAC you have different equipments, different services. Electrical we have also different services, means communication, earthing, communication, this emergency power cable tray. So this is the full system. So major contributor all of this non-structural is HVAC and electrical, while the importance for seismic point of view is always lead to the life safety services, but HVAC and electrical are the major contributor too. So as we have discussed, just the introduction, values, costings, investments about the non-structural and earthquake introduction we have discussed. Now we are going to start this. How does this earthquake or this all seismic events affect on this MEP system? How these seismic forces can affect on MEP system? So in non-structural components, it has for the MEP, it has non-structural component. In non-structural components, we have different kind of mountings. We have ceiling suspended, we have floor mounted, we have wall mounted as well. So it's basically we have different kind of reactions, we have different kind of effects because of that seismic event. So for the ceiling suspended services, it could be the collision between the pipes and sprinkler pipes hit building structure or other MEP system. So that would be the risk to for the destruction because of the collision of the piping or any ceiling suspended services. This is specifically for the floor mounted system. While we are discussing, while we are taking this into account, this floor mounted, it has also its own effect, kind of, because of the earthquake movement. It is every equipment has its center of gravity, which is in the center of the equipment, and because of that CG, the equipment could fall down because of any movement at the basement. So there could be the overturning there could be the risk or chance because of the earthquake for the overturning of the floor mounted equipment. Then fittings could be break due to twisting, and this coupling, this connections could be come out because of that movement. So we have different measures to take, we have different measures to control this all seismic forces, all these effects from MEP system. So majorly for the floor mounted system, we have bracing, which is like kind of different kind of bracing, which we will discuss in detail in this session. And then anchoring, which is bracing for the mostly for the ceiling suspended system, and the anchoring is for this for floor mounted equipment, wall mounted small panels, battery panels, all these kind of equipment which are directly fixed to the structure on floor or on wall. Then flexibility is very important, because differential movement is expected because of this seismic movement, and then flexibility we need to consider in our designs by using, let's for an example, like from ducts to equipment, we have flexible duct connectors, which is like which is making the system more flexible. So that also be the part of this system to avoid any kind of twisting or like breakage because of the movement. We should have some flexibility and tolerance. So clearance, it's like we are not considering, we don't used to consider normally in the normal practices, but clearance would be the like could play it's very important to consider the clearance during the design, because if like system piping things are close with each other, then there would be the chance, there would be the risk for the collision. So if we have a more proper clearance, then because of those movements we can control that collision during that event. And this load path engineering system needs to be designed very well, and then product should be tested for the application, means the whatever the application of the product, it should be certified and tested for those applications. Then this is not the normal installation, this is not the normal kind of system which we are going to install. So it's better to inspect after the installation and get it certified from the specialist. So everything should be would go smooth while like after confirming the installation as well. So inspection is most important part after doing all these things. So bracing, we have different, like as I told you, this bracing and anchoring. So bracing we can use for the floor mounted service, ceiling suspended services, pipes, conduits, bus ducts, cable trays, ventilation units, suspended equipment. So it's basically bracing is used to control for the all services and equipment which are ceiling suspended from the ceiling, which having the ceiling suspended mounting. Then anchoring is just for the panel boards, floor mounted, mainly for the floor mounted equipments. While we are talking about the wall mounted, we have panel boards, switch gears. For floor mounted, power generators, air conditioners. So that anchoring shall be very important for this seismic point of view. For this, an anchor should be seismically certified for this application. So now, after the effects on MEP system, as I explained, bracing is the most important part along with the anchoring, because majorly we are dealing with the bracing, and then anchoring is a part of it. So seismic bracing system, and now we will discuss about what kind of bracing systems we have and what kind of bracing system could be applicable to control this effect of seismic forces. So initially we'll start from rigid bracing system. So rigid bracing system has its own, every system has its own advantage and limitations. So rigid bracing system it has different combination of different channels and different frameworks, and along with the different accessories. And then we have flexible bracing system. In flexible bracing system, it has its own advantages. Then we will discuss it here. But the idea is same, to limit the movement rather than the prevent, and it's very easy to install. Can be linked directly with the clamp, can be linked directly with the pipe. So no more accessories required. And each cable is each support required two cables with having the equal distance, and these all cables having different load carrying capacity to control the seismic forces based on the different load requirement. So now we are comparing here rigid bracing system with cable bracing system. In rigid bracing system, as you know, it is not flexible. It has the kind of channel involved in the to brace the system. So compression and tension, both kind of reactions are there. But in cable bracing system, only the tension force shall be there during the seismic event, or the only in terms of reaction. So cable bracing system, it has some advantages or benefits over the rigid bracing system. And the wires which we are using, it's aircraft pre-stretch wires, which is specially designed. This is not the normal wires. These wires are specially designed for this application, and resist loads in tension 100% of the time. So obviously, then it has one of the best advantage of it. This is there is no KL over R limitation. Radius of gyration limitation are not there. Whatever the drop from the ceiling, whatever the length of wire is required, we can use it. Because if you are using some rigid or channels, then it has, because of the length, there would be the changes in the reaction. But in wires, if you have a long drop or if you have a long length of wire, then we can use it because it has no any KL over R radius of gyration limitation. So, and it's easy to install. It's because you can wrap around the pipe, you can wrap around the service, and then clamp to the ceiling. So while designing seismic restraint system, it has few standards to be considered. So I'm just sharing here some major main standards which we used to consider, which includes international building codes, international existing building codes, American Society of Civil Engineering, NFPA, and Uniform Building Code. Some projects required following this UBC, and some projects following IBC. So both have to consider based on the requirement and specification. Then seismic restraints by ASHRAE, SMACNA, NEMA, and the other standards as well from ASME. So these are the standards which we used to consider for designing any seismic system, and that needs to be considered for design any non-structural seismic system, along with the compliance or this all specs and the details. So in bracing system, we have different kind of bracing, means lateral sway brace, longitudinal sway brace, and sway brace, four-way brace. In lateral, it is brace perpendicular to the axis of the pipe. It's concept about the direction. Why it's lateral, why it's longitudinal? Because of the direction. So in lateral brace, the wire having the direction along perpendicular to the axis of the pipe, perpendicular to the axis of the service. In longitudinal, it is along to the longitude, it is along to the length of the pipe. Four-way brace, it has four-way system which can be used for the riser mainly to cover both longitudinal and transverse. Lateral transverse, I mean here the lateral sway brace. Then lateral sway brace has its own standards to consider the span, and longitudinal sway brace has its own standards for the span. And as you can see here, it's it could be applied on every feed and cross main line for the piping, and it could be used in majority is greater than 65 mm diameter of pipe, and it should be started from 1.8 meter from the end of the pipe, and maximum allowed spacing is 12.2 meter for longitudinal for transverse bracing, lateral bracing. Now in longitudinal bracing, it has the same system, feed and cross, it needs to be braced, and it should be installed from the end of the pipe from within 12 meter, and then maximum allowed spacing is 24.4 meter between from each support to another support. It is the maximum 24, and this 12.2 is a maximum, but based on the load requirement, if there is more loads, then we can install it, we can use multiples, but this is the 12.2 meter is the maximum span which we can consider. Risers has its own standards to consider for the bracing system. So if the top of the riser exceeding 1 meter in length shall be provided sway brace, and can be done four-way brace, because it's more logical to use a four-way brace in risers because of its vertical. Distance between sway brace for riser shall not exceed 7.6 meter. So this is the riser as we have here. This for the horizontal running 12.2 and 24.4. In risers vertical we have like 7.6. The support or span should not be exceed from 7.6 meter. Sway bracing shall not be required where risers penetrate, because risers sometimes they are penetrating through the ceiling, through the structure, and then it is already it has no chance for the movement. So that needs to be considered in the while designing of any riser bracing system. So in seismic bracing system, now we have done this seismic bracing system where we have discussed lateral sway rigid cable bracing system both, and advantages of cable bracing system over the rigid bracing system. And then we have discussed different type of bracing: lateral brace, longitudinal brace, sway brace, and what is applicable, what standards shall be applicable for horizontal run and what standards shall be applicable for the vertical risers. Now here we will discuss about design methodologies to design any system for the non-structural. So we have few important parameters needs to be considered for in order to design any seismic restraint system for non-structural components. Initially, we need to review and assess the project soil profile type and site class. What site class it is, what is project soil profile type it is, which we can get easily from the soil reports of any geotechnical reports from the projects. Then importance factors. Importance factor has its major role to categorize the services with structural and life safety and non-life safety, and building occupancy categories, which we just had some overview. Building occupancy categories, now we will discuss in detail. Then seismic design category, which has been the design categories which has been designed based on soil profile type and some site coefficient parameters. So based on that computation, we have some values, and that values we need to compare to match the seismic design category. So let's start first from the soil profile type. As you can see this from IBC, ASCE, this we have this different soil profile types, and this A, B, it depends on the shear velocity of the soil particles, and based on that particle velocity, it is categorized in different site classes. So A is a hard rock, and then B is the rock, then C is the one which we are facing mainly here, very dense soil and soft rock. So for any component, if we have, because in order to design any seismic restraint system, we have to categorize the structural, this non-structural parts in life safety and non-life safety, because that is very important while making any seismic assessment, because most of the projects they are considering the life safety. So we need to check whether it's based on the soil profile type and seismic design category, is it required for life safety, and it's required for all services. So before going to that step, we need to check which life safety services it is and what are the non-life safety services, and at how these services are categorized in terms of importance factor. So here we have two kind of importance factor, which is 1.0 and 1.5. 1.5 is for the fire suppression, is for the 1.5 IP is for those all services system which are related to the life safety, and these includes your firefighting system, smoke management, this all services which could be hazardous for the human life safety. And the other, which is IP 1.0, which is for all non-life safety equipments like the HVAC, which is like air conditioning, like plumbing. So these are the comes under this category of 1.0. So now this is nature of occupancy. As per the IBC, it's categorized from 1 to 4, and let's say this it's one represent those buildings which have very low hazard to human life, like small buildings, G+1, or some agriculture facilities or a small house. But the other one, they have just written here from 1, 3, and 4, but it has some in between 1 and 3. Then we have building and other structure which represent like substantial hazard to human life, like school, assembly halls, water treatment facilities, or any other how we categorize this three, it's occupant capacity is greater than 5,000. So this is the like main criteria which we can like categorize or differentiate any occupancy category, while we are confusing or while we have some issues to like find out the same exact name of our occupancy category. Then hospitals, fire rescue, ambulance and police station, emergency and the power plant, aviation control, these all are come under the category of 4, which is more severe. And those severe needs to be, for seismic point of view, structure is more severe, then we need to use more design the system for seismic. This is based on this soil parameters, based on site coefficient, soil profile type. It has some values. Based on this computation, we have some values in terms of G, and this by using single line interpolation method, we can get here the based on occupancy category, and based on SDS value, we can get the seismic design category, which category it is. There are basically A, B, C, D categories, and D is the most severe, and the C is like less severe, but it is considering for the life safety services. A and B, it has nothing for the seismic. It's totally exempt from the seismic. In terms of design category, because we have lot of in seismic, we have lot of ABCDs. So in design category, it has own ABCDs, and then soil profile type, it is different. So seismic design in terms of seismic design category and in terms of importance factor 1.0 and 1.5. Let's say we have seismic design category based on some computation on profile parameters and the other parameters. We have some values for seismic design category, and seismic design category we have got C. So if seismic design category is C, so seismic treatment is exempt from those equipments which are importance factor 1.0, like non-life safety, and it is required only for the life safety, which is 1.5. If seismic design category is D, then it is required for both 1.5 and 1.0 and 1.5. The same is follow for the E and F, but mostly this is we are not in the region which is that kind of severe as E and F. So the major is the like most probably is for D in the worst cases. So while we were discussing before based on seismic design category and life safety services and non-life safety services. Now here we are discussing about adding one more item, which is pipe sizes. Means you are dealing with firefighting pipes, you are dealing with some pipes, and then both like life safety and non-life safety. If you have seismic design category C and your pipe size is 65 mm, then it could be exempt from 1.0 and it's required for only for the life safety. Then D, E and F, 1.0 and 1.5 both required for the same size, as the same 78 required for 3-inch pipe. 1.0 is exempt, 1.5 is required in inside category design category C, but in design category D and F it is required for 1.0 and 1.5 both for these sizes. So if the smaller size is required, then obviously the higher sizes shall be involved. So this is the like concept to categorize the pipe sizes or to differentiate seismic requirements based on the seismic design categories. So we have some method to calculate the seismic design force as per American Society of Civil Engineering, and this seismic design force has some like formula or method to calculate the seismic force. SDS, as you all know, right? The based on soil parameters and the profile type we can calculate, and then AP is amplification factor on based on different equipments, and IP is the importance factor. RP is the response modification factor for each equipment is different as per the different tables from ASHRAE standards. Then Z over H, Z is the height point of attachment to the structure. Then H is the overall height, and WP is your component operating weight, which should be dynamic weight. So this is the like method for to calculate the seismic forces. So this seismic forces we have calculated here for this is journal seismic force. Now we have upper and lower limits to like to to counter check our values. So this force is not to be greater than this 1.6 and this equation, and this force must be at least 0.3 this equation, the second one. Our FP value is coming lesser than this, the force, this less than this force 0.3 SDS IPWP. In that case, we need to consider the force which is coming from this equation. So that is the reason it should be at least, the force must be at least by this follow this equation. It is this, your vertical component must be designed for vertical based on these loads, and it has this factor 20% of your SDS and WP. So now these are the design methodologies which we supposed to discuss. Now we have some application examples which I can make it more simple to explain you how we can use these all parameters to design any system. Let's say we have one school, and this school having this school is come under this risk category 3, and nature of occupancy is 3 for these schools. Then we have, let's say we have pipe for 100 mm diameter, which is firefighting pipe. Let's go again to this table, and then this table shows you this, if seismic design category is D, E and F, and seismic design category C, what is the requirement. Then here is the requirement, it's required, IP is required in all means, by all cases it's required. So now we have some calculation for this pipe along with the other sizes as well. Let's say we have this, by using this equation, by using this force, we have computed this SDS, this as based on soil parameters, we have computed SDS and SD1, and then based on this formula or this equation, we have computed seismic force at certain angles, because wires shall be applied at some angles. We cannot consider the vertical force for wire application or any application for bracing. Angles needs to be considered. And then again the same formulas for maximum and minimum, need to follow the minimum, and then vertical should be designed. Again the same thing for the first transfers, then longitudinal. It has the difference of span, and different spans we are using for both. As per the standard transfers, span is different, should be different from the longitudinal, unless it is four-way sway brace. And then here we have some pipe weight, factor of safety, and anchor design shall be 1.3 times of the FP. Here we have some markup sample of the project where we used to submit, how we used to work. And these are the, as you can see here, it's different markups are available for the different transfers and longitudinal supports. So it's a part of our design system, because you cannot install without these markup drawings, and that markup drawing needs to be designed by a specialist and by the supplier or the who's designing the system. And here we have some few typical details for equipment, piping. If we have different installation method, piping, this connecting to the clamp on the right side, and the left side it's wrapping around the pipe. Here we have some installation pictures. This is for the left one, this for transfers, and this right top one is longitudinal brace. So these are the kind of bracing which we used to done on site for our seismic system installation. We have wires which is really easy to fix, and these wires are UL-ICCS listed and complying with all national fire protection authorities, and the system is designed according to IBC and UBC based on the requirement and specification. And this wire has its own strength, and it's categorized by different colors to represent different load carrying capacity. And these are the pre-stretch aircraft cables, not the normal steel wires. That needs to be considered in any while choosing a wire, because normally we cannot choose the normal wire for this application, because those pre-stretch and normal wires having different behaviors in different application. We have gripper system, which has ball bearing mechanism inside, and then it can be pull from the trigger. Then this you can insert the wire and take the wire from the other side and make a loop. and it's very easy to install. No any swaging method required. Normally for the, if we are using crimping sleeves, then in that case we have to use the crimping swaging tool to compress or to punch the sleeves to make the make a loop. And it's also, it has different standards, it has different, it's tested for this application. And it's like major concept is to eliminate the swaging process, which is the complicated on the side during installation. And we have bracket system, which is very simple to install. Products are very simple to install in seismic, but the complications or the assessment design is the most important part before doing any installation. Here we have some rigid installation for the seismic bracing system. Then we have this accessories which we are using to design any rigid bracing system. And for the, because we were discussing about the floor, the ceiling suspended services, equipments. Now the thing is, floor mounted equipments needs to be in the account for seismic assessment. So we have anti-seismic vibration isolators. This picture is showing one of our project which having this generator, and generator is, we are using anti-seismic vibration isolator to avoid any uplift force by applying seismic anchors as well. So this vibration isolator covering both features, isolate the equipment vibration as well as to avoid the uplift force because of the earthquake. We have seismically certified anchors, which could be which is the part of our system, and wherever we have seismic requirements, we are recommending these anchors, which is certified for seismic applications C1, C2 categories. Thank you so much. So I'm looking forward for your questions, so then we can continue this discussion.
Thank you, Haris. We have some questions actually, so I will read some of the questions, but I'll ask the attendants if you have any questions to just ask them now, so we can get to all of them. The first question is from Mr. Dharmesh Joshi, and he's asking if should anchors be seismically designed along with support system?
Yes, thank you for your question. And this anchor should be designed for any seismic application, and anchor should be certified if you are using in any seismic support installation.
Another question again from Mr. Dharmesh Joshi, that's asking if the flexible bracing system has FM approval.
We have UL listed products for seismic bracing system, and that is designed for and is complying also this NFPA 13 and ICCES listed as well.
Thanks, Haris. Any more questions? We have some of the attendees asking for the slides after the presentation. We're gonna upload a recording of this presentation to our social media pages, so you just check it out. Okay, let me check. Okay, I have a question of how to incorporate, because now the questions are pouring in, how to incorporate the zone of influence on the design.
Actually, there are different methods to consider while we are designing. We used to consider the zone of influence, where the majority of the pipe having the more forces and affecting for those pipes which having low loads. So zone of influence are the part of our design while we are designing any seismic bracing system.
There is another question here. Mr. Samir Soliman, correct me if I read your name wrong, but he's asking the bracing inclination angle shall be 60 degrees instead of 45 degrees to get the worst case. Can you comment on this? What should be the best angle, or what angles can be considered for the system, Haris?
Yeah, angles is manageable, and it's like based on different, because wire has its own load carrying capacities while you're using wires, and based on different angles it has different loads. So wire can be applicable at any angle, and based on that angular force we can use different models of wires to like control that load.
There's a good question here for Mr. Halil Aras. Mr. Halil is asking, what about the branch lines in firefighting service? Is there any certain length for this branch to be seismically restrained? What do the standards call for that, Haris?
Branch line also have the same like standards, and this for the span point of view, transverse and longitudinal spans shall be followed the same in case of any branch or main line. But again, the thing is, while we are handling this branch lines, we need to counter check the zone of influence it's affecting on the other ends. So this is the part of our design while we are doing this assessment.
Mr. Mohammed Yahia is asking how to choose anti-vibration isolators, so vibration isolators for reciprocating machines. So I'm assuming this is for seismic events as well.
Yeah, anti-seismic vibration isolator, like based on the load requirements and different RPMs of the of the equipment. So based on different equipment RPM, this ASHRAE has some recommendation to use which kind of isolator. So if it is for the higher RPMs, like majority is using, or is major recommendation is for spring mounts. So spring mounts, anti-seismic spring mounts shall be used in case of seismic restraint system consideration. If it is normal vibration isolator, then normal vibration spring isolator shall be used.
Sorry, Mr. Sumit Pereira is asking, can we purchase this product in Sri Lanka? I can go ahead and answer this one. Yes, yes, you can. I'll actually going to put you in touch with our Sri Lanka team. We have a dedicated team over there, so they can assist you locally on your next project. What's the best solution for that? And then, of course, technically, we'll have full support from us, from them. We are all the same company, so don't worry about that. So I'll get you in touch with them. I'll ask them to get in touch with you as well, and we'll proceed from that. Okay, so Mr. Sai Krishna, how to choose seismic design category?
Based on different soil parameters, site coefficient and soil parameters, based on those computation, it has formula, and then by using those formulas, we have to we need to compute some values, and that values we need to by using single line interpolation method, and in the ASHRAE table, then this ASC table, then we can get easily this seismic design category based on this computation value.
Sorry, Sunit is asking at what distance should be the first support for risers?
It should be installed before, from the end of the pipe, it should be installed not more than 0.6 meter from the end of the pipe.
Another question from Sai Krishna. Is seismic bracing required for floor-mounted pipes in terrace, so in rooftops?
Yes, obviously it's required, and while using this floor-mounted seismic anchors, seismic certified anchors shall be recommended.
Sorry. If anyone has another question or something else that we can immediately answer, please go ahead and post them up. If you don't have anything that you remember right now, you can get in touch with us as well, no problem. Just wait a couple of minutes to see if there are more questions coming in. Okay, I believe that is all. Thank you all for attending our webinar. We are very happy to see all of you present today. Please stay tuned to our social media pages because we are going to plan a lot more events like this. We hope that you like this session and that was a very informative session for you.
Thank you so much all to attend this webinar. If any clarification or any needs to be clarified, just let us know.
We'll just show you the last slide, and that shows our contacts as well. Right, so here you can see there's my email, there's Hari's email, so you can get in touch with us. If you are in the zone, you can also give a call, so wherever it's the most preferred method for reaching out to us. Just go ahead. If you have any more doubts, we're going to upload this recording to our social media pages. Just check it out if you have any more doubts, and if you remember any questions, just send an email to us or give us a call or any method that you prefer, and we'll get back to you. Thank you so much for attending.